A collection of computer servers, known as a service farm, can provide a number of network services for people connected to a company's data network. One service shown here is a web service. This web service provides this organization with a company website. An application layer called Hypertext Transport Protocol, or HTTP, defines how web information is transferred between a web server and a web client. An example of a web client would be a browser such as Google's Chrome. This presentation explains the function and operation of the more well-known application layer protocols. The Telnet application layer protocol allows a user to remotely connect to a machine for the purpose of making some type of change. This might be a configuration change, if this machine here were a router. Or if this is a server, a user might remotely log in using Telnet to perhaps add a user account to the company's network. Two different software modules are required for this type of service. We generally refer to them as a server module and a client module. These are two different pieces of software. In the Windows world, this software is often called a service. In the Unix world, it's often called a daemon. Both are what are called background services which run and provide this Telnet application, a remote login application. The important consideration here is that both are going to use the rules defined by Telnet to exchange information and to allow clients to remotely control some feature on the device that the remote client is logging into. 5 common protocols that we're going to look at are DHCP, and this provides internet addressing. DNS, which we'll look at in this presentation, and this provides a way to translate English names into numeric internet addresses. We'll call this names resolution. Telnet, which we just looked at, which provides remote access to some network device. The Hypertext Transport Protocol, which provides web page information distribution between clients and servers. And a file transfer protocol, which allows users to send files back and forth. Network software is often categorized as one of two types: using application layer services, or the software may be network aware. We're first going to look at our protocol stack here. And here we have our upper layers, the application layer being one of these. Network-aware software is software which has some of the application layer protocols already built in. And examples of this are software that provides email clients or a web client. And that software can bypass these layers in the protocol stack, and they can communicate directly with the lower layers. So it's not that this functionality doesn't exist, it just exists in the application itself, such as the Chrome browser or whatever, maybe an Outlook email client. Other software programs may need the assistance of application layer services to use network resources, and so they communicate with the protocol stack right at the top. And examples of this are a file transfer or network print spooling. And by print spooling, we mean sending a print job to a remote printer on the network. Before we look at some application layer protocols or services in detail, we first have to understand how network addressing works. So let's suppose we have a server and we have a client machine, some distance apart. We'll assume this is a web server. In order for a message to be sent over a TCP IP network, each computer must be assigned a numeric address that's unique on the network. We won't go into the format of this address, but this might be what the address looks like. Since the internet is global, these addresses have to be unique anywhere in the world. So let's suppose this is the Acme network, company, and a remote person wants to connect to their web server. What has to happen is that an information packet has to be assembled which contains the source numeric address and the destination address. Now, this can be accomplished on the client by opening a browser and in the address box simply putting in the destination numeric address. One problem is that there are hundreds and hundreds of servers out there, so keeping track of all these numeric numbers is quite a task. Also, as humans, we don't work really well with numbers. We often make mistakes, so this is fairly error-prone. To make it easier to access network resources, domain names were invented. And a domain name is a way of giving an English type of name to some network server. So for instance here, we might have acme.com. Now, a person with a browser simply needs to remember the domain name of the web service they want to use. And so in the address bar of the browser, they might type something like this. The major part of this, acme.com, is the domain name. The part in front, the HTTP, defines what protocol we want to use or what rules when we communicate between these two, the client and the server. Together, this forms what is called a universal resource locator, or URL. But we said that we have to use numeric addresses in order to form our packets. So how do we get away with using this English name here? Enter the application layer protocol called DNS for Domain Name System. All computers have built into its memory the numeric address of a local, what is called DNS service. So this computer knows that its local DNS service is at this address. And what it's going to do is create queries to those domain names that it wants to access. So let's suppose this client wants to access acme.com's web service. The first thing it does is send a DNS query or question to the DNS service. And it's going to ask simply, what's the address for acme.com? The DNS server is going to resolve that name by contacting other DNS servers in the world, one of which has what's called the authority or knows about acme.com. And this is a multi-stage process. We won't go over it here. But eventually, this DNS server gets a reply, which is sent back to the client and basically answers the question, acme.com is at this address. So now the client, of course, it knows its source address. It now knows the destination address that it wants to use. And so this all happens behind the scenes. So the user simply typed into the browser http acme.com. What happened behind the scenes as part of the software and the protocol stack is that a DNS resolution was performed where a DNS query was asked of the local DNS server, an answer was back, the numeric address of the destination was found, and then a packet was constructed using the source address and the destination address, and finally that travels out through routers to the web server. The web server responds with the web pages which show up in the client browser. And this can only happen when you have a DNS operating in your network. Now, if you don't want to use English names, you always have the option, if you know the address, of typing the numerical address in here, and then you don't need the service of DNS. We almost never use numbers. We almost always use these English domain names to contact resources on the network. We'll take a quick look at domain name structure, and we'll look at this more throughout the program. It's a bunch of names separated by dots. And at the right-hand side, this part of the domain name is called the top level domain. You'll see things like CA for Canada, EDU for education. Most countries now have their own country code. Then you have a second level domain, which is often reserved for the organization or the company. And you can have subdomains which go off here. Third level, you can even have others. You could have a machine name here or a host name, which would be a fourth level, and so on. We talked about our local DNS server contacting other DNS services in the internet to resolve or find the address of a domain name. DNS servers are arranged in a hierarchical fashion or tree structure. And at the very top of the tree structure, we have this root DNS series of servers. And they know where all the DNS servers are that can resolve names ending in .com, .org, .au, all of these. Now they simply point a query to the proper DNS service. So at the very top are these root DNS servers. Then we have a series of servers. So this DNS server is going to know about most of the .com, where anything ending in .com resides in the world. This server might be responsible for all the ones ending in .org. So these are the top level DNS services. So this might be .com, .org, and so on. And finally, if I want to find out Cisco.com, there's an actual server that has the authority for storing the numeric address of the Cisco.com domain. And of course, there are several other servers for all the other comms out here. So these are second level or secondary level. And so the tree works down to the third and fourth level domain servers. So one server somewhere has the authority or knows about the address, but It's found through a tree structure. There's not any one system that contains all the domain names in the world. It's distributed through this tree structure or hierarchical structure. So this was a quick overview of application layer protocols. We looked specifically at some details of the DNS protocol, a little bit at the Telnet protocol. We'll look at some more common application layer protocols in future tutorials.